Rational and irrational numbers. These are two main groups of numbers, and we need to know a little bit about them. And we're going to start by defining irrational numbers, because we've just been looking at non-terminating and non-recurring decimals, and that's what these are. Irrational numbers are non-terminating and non-recurring decimals. That means anytime we get a number that goes on forever and ever and ever in the decimal zone and doesn't fall into a recurring pattern, it's an irrational number. Now you'll remember that I said that when we were investigating getting a decimal from a fraction, if we'd used a fraction to get the decimal, it had to be either terminating or recurring. It couldn't be non-terminating and non-recurring. And that's because the actual definition of an irrational number is that, not it because I've got plural. They cannot be written or calculated from a fraction of whole numbers or integers. So that's your important definition of an irrational number. It can't be written as or from a fraction of integers. Now, if it was a fraction with pi in it, fine. Pi isn't a whole number, it's not an integer, that's not cheating. And the reason they're called irrational is because the word ratio means fraction, not fractional numbers. So our irrational numbers can't be written as a fraction, and they're usually the special numbers or roots, square roots and cube roots and things like that. So a couple of really well-known irrational numbers are pi, spelt Pi, 3.1415926535897, it just keeps going. There are other special numbers such as E, Euler's number, which starts 2.71828182 and just keeps going. There's one called phi, 1.6180339, I don't remember. So there's lots of special numbers. Pi is the only one I need you to recognize. And of course, another good example of an irrational number is the square root of 2, where we're saying what times what equals 2 is our question. And of course, we can't think of any number off the top of our head that multiplies by itself to give 2. So the square root of 2, remember if you get a root answer and you want a decimal, you push this button, 1.4121, etc. So that's our question. What times what equals 2? Question mark. No idea. Square root of 2 is 1.41213562. It just keeps going forever. So these are irrational numbers. In contrast, rational numbers can be written as a fraction of whole numbers. So ratio, fraction. So if you can write anything as a fraction of whole numbers, it is a rational number. So this is obviously most of the numbers that we deal with in high school maths. So if it's a fraction, of whole numbers, then obviously it's rational. Any whole number, any terminating or recurring decimal, and, oh, I should have put little stars or something here. This one might be tricky. Any root that gives a rational answer. Or value. So let's break some of those down. A half, it's a fraction. It's rational. 1/3, it's a fraction. It's rational. 3, a whole number. Any whole number can be made into a fraction by putting it over 1, because 3 divided by 1 is still 3. So it's rational. -2, still put it over 1. It can be written as a fraction of whole numbers. It's rational. 1.8, terminating decimal. If I wanted, I could change that into a fraction by writing it as 18 over 10. Double check if you want. 18 divided by 10, 1.8. 0.3, recurring. We'll go through later as an extension how I would change that into a fraction, but you should remember from last lesson that's 1 over 3. It's a fraction. The square root of 25 is saying what number squared gives me 25. If you're not sure, grab your calculator. Square root of 25 is 5, which means 5 over 1. It's a fraction. So any rational number can be written as a fraction of whole numbers. How to tell if a number is rational or irrational? Either you could, of course, just follow your recognition rules that I just taught you, but if you're feeling a bit uncertain, evaluate it with your calculator, especially if it's a root. Then, if it's non-terminating and non-recurring, it's irrational. Everything else rational. And if you want to prove it, you can write it as a fraction of whole numbers. So state whether each number is rational or irrational. 0.6, recurring decimal, it's rational. And you might remember that's 2 over 3. -3, whole number, rational. If I wanted to show it as a fraction, I'd write -3 over 1. You don't have to do this, but that's how you know absolutely that it's a rational number. 2 over 3, rational, it's a fraction. Root 16, be careful with your square roots. Evaluate it first, because square root of 16 is 4, because 4 times 4 is 16. So that equals 4 over 1, so it's rational. Pi we recognize, we know that's irrational because we know it keeps going forever. Square root of 5. If you're not sure on the square roots, evaluate it. Remember to push the button that says please give me a decimal answer. If it fills up your calculator screen and you don't have a recurring pattern and it's a square root, you're pretty sure this is irrational. So if we wanted to show that for these two, 2.236067978 just keeps going. Pi is 3.14159. 26535 just keeps going. How about this one? 6.31236489101 ... says it keeps going. No evidence of recurring pattern. Irrational. 0.831246, it stops. It doesn't keep going. It's terminating rational. It would be challenging to write this as a fraction, but we could by writing it without the decimal point over a 1 and 1, 2, 3, 4, 5, 6 zeros. A big fraction, but still a fraction of whole numbers. Root 2 over 3. Be careful, because this is not a fraction of whole numbers. The square root of 2 is not a whole number. If you're at all uncertain, evaluate it. Square root of 2 over 3, evaluate. That looks pretty irrational to me. So, rational and irrational numbers. You need to be able to tell me if a number is rational or irrational, and you would need to be able to give me the definition of rational and irrational numbers. Rational can be written as a fraction of whole numbers. Irrational cannot be written as a fraction of whole numbers.